Let's back to the next chapter, RAG workflow in the sense like, as we, we talk about in our previous chapter, like what exactly the RAG is, what are the different components of the RAG, they are really works together, right? So now we'll talk about how the RAG workflow works, right, in the RAG system. What exactly the workflow in the RAG system? So to build a RAG system, it's crucial to understand the foundational component that go into and how they interact with each other, right? That's why in this section, let's explore each and every elements in detail. Okay. So in our previous chapter, we talk about like how exactly what are the different elements and basics of RAG and all. And now here we'll try to discuss more and more about like different components a little bit in detail, right? So here, if you see the whole architectural diagram, let's try to decipher this whole diagram into different components. In the sense, what it will be, different components will be, one of the component will be chunking, and the other component, will be always, embedding, and then storing the data into the vector database and generating the response out of that, and feeding that particular augmented data into the LLM, and then finally we'll generate the response for the user, right? So in that case, so we'll go step by step. Then what we'll do, we'll start with some external knowledge. External knowledge means some of the input data, right, that wasn't seen during the training. For example, we have trained with some data set and we are trying to input some data which is not seen yet earlier, or the LLM is not trained yet on that, right? Let's think of like the custom knowledge base, right? This knowledge base, right? So now what we'll try to do, so if you think of the flow of the components, it's look like this. First, we are going to create the chunks out of the new data we are trying to train, right? Trying to provide or trying to search. And then what we are going to do, we are generate the embeddings out of those input data or chunk we got. Then we'll store those embeddings, the generated embeddings, into the some vector database, right? And then what we'll do, we'll get the user input or user query. So once we store all this trained data and embed into the vector database, then of course, what is the next thing? Next thing is like, okay, we'll talk to the system, right? Talk to the chatbot or whatever you have created, because we have already trained the data behind the scene before asking the question. So now user is asking the question or any query. So that query, what it has to be, it has to be embed in the sense like that particular query has to be converted into a numerical format. Okay, where the where where it the LLM can understand that, the whole flow can understand that what to do with that particular numerical set of data, right? And then it will try to search in the data store and prepare the response out of that and send it back to the user, right? So that's how the whole process works out. Next thing will be creating the chunks, right? If you think how to create a chunk out of data, this is our input data, right? And here is we are creating the data, right? If you think of like the first step is to break down this additional knowledge into chunks before embedding and storing into any vector database, right? So this is how we are trying to chunk it, right? So we do this because the additional document can be pretty large, right? Thus, it is important to ensure that the text fits the input size of the embedding model, right? So if you think of like always we heard about like Llama 2B llama 2b 80 no, llama 2 2b llama 70b or llama 3 and other Mistral models. There are a lot of models available, right? So every model has their own size. So you cannot go beyond that size, right? So that's how we talk about, like, whenever, I mean, we are trying to add additional information into the system. So we need to also understand the size, right? So it's important to ensure that the text we are sending into, it really fits into the embedding model, right? So that's how it's, while you are trying to chunk the document. So we are chunking into multiple pages, right? So moreover, if we don't chunk, the entire document will have a single embedding which won't be of any practical use to retrieve relevant context, right? So if we are not chunking, then it's first thing is, like, very difficult to search in a thousands of pages of document. It's always difficult to search in that. And second thing is, like, whenever we are asking question, it will not give any specific information, right? Correct information to us, right? Whenever we are asking question on anything on top of that. So that's another thing, right? So that's why we are chunking. So if you think of different kind of chunking, what are the different kind of chunking we can really deal with? So I've written one article in LinkedIn, so you can follow that as well. So there are different kind of chunking we can, strategy we can follow. So out of those, here, if you can see, like, fixed size chunking. Here, what you are trying to do, you are just splitting documents into multiple parts with fixed size. Your size is fixed, and whatever it may be, it will divide it into that many number of songs according to the fixed size, right? And the other one is the semantic chunk. This can be a chunk into in a fixed size, and the other one is the semantic chunk, where you are converting you know chunking by sentence, or you can keep adding the new segments until cosine similarity drops drastically. There are some mechanism you can really follow through according to your use case, right? And there is another called recursive chunking, and where you are recursively chunking a particular any document, right, according to the segment and size of chunk size limit, and keep chunking it, till you are not reaching to a specific point, right, or size. So another is document structure, right? So the document structure, you can say, like, structure based chunking. For example, by you are chunking by paragraph, okay, or you are chunking by inherit structure, some structure you are trying to follow, or section by section, or you can say, like, okay, you have in documents, you are putting header one, the first level header, second level header, third level header, right? So you can also chunk by that, right? Those are also structure based, right? And another is a LLM based, right? You provide the document to the LLM. Now let the LLM generate its own own chunks, right, according to its own algorithm, right? So that is another thing. So the second step is generate embeds from the chunks, right? So what exactly the how how to generate the embeds embeddings from the chunks, and what exactly this step does, right? So after chunking, we embed the chunks using an embedding model, right? So if you see here, the chunks are there, and we are trying to embed it and sending into the embedding model. So we have to write our embedding model, how to embed the data, or we can use we can use some uh, you know, foundational model from open source, or any proprietary LLM you are using, and then that will be converted into multiple chunks with embeds, right? So since these are these are context embedding models, not word embedding model, right? So there are two different. One is context embedding, and another is word embedding. So I'm just throwing lots of words like dictionary words, right? So how does it matter? It will just store it, right? There is no relation between those words. I'm just throwing some words and store it. But when you are talking about context, means it's kind of conversational context, in the sense like if you are talking about something in past 1 hour or past 10 minutes, if the whole next conversation should be around that particular subject, right? So in that case, that's what called context. Whenever you are talking to any generative AI or chatbot, so you'll see like whole conversation goes with similar context, like what is your problem statement. First you are providing your problem statement, and according to that, around that whole conversation goes on and on, right? So that's called context. So context embedding model is little different from the word embedding model, right? So a model like bioencoders, which I mean which is a little bit, advanced, that probably we'll discuss more in a later point of time. So those are highly relevant, where we deal with whenever we are dealing with the context, or contextual embedding, right? So that's where it talks about, right? So the next is like once we got the embeddings, so that embeddings has to be stored somewhere. Where? Into a vector database, right? So, so if you see, these embeddings are then stored into the vector database. So whatever these were the outcome of our previous stage, right? The creating the embeddings, right? Now these embeddings has to be stored into the somewhere in the database, the vector database, right? So this this shows that a vector database acts as a memory for your RAG application, right? Since this is precisely where we store all the additional knowledge using which the user's query will be answered, right? So any question uh, being asked by any user, now everything will go through this one. Those questions will be answered using this vector database now, right? So ideally, vector database also stores the metadata and original content along with the vector embeddings as well. Then how otherwise how it will convert the numerical to text again, right? So all these things we are trying to store is like embeddings. While we are asking a question, that question getting converted into embeddings. Then it's try to search in the vector database. So while it's trying to search the vector database, what exactly it's trying to search? It's trying to search the numerical format, one of the numerical format inside the vector DB. Now, once it find those numericals, neighborhoods, those are again map with some actual content that's already stored, right, in the database itself. Now, those related data will be returned to the as a response to the user, right? So that's how it will be. So with that, so now the vector database has been created and information has been no information has been stored into that. Now the now further more information can be also added to this particular database wherever it's needed in future, right? Now, let's move to our next stage. Next stage is get user query, right? So now all those input data information has been stored embedded into the data store. So now it's time to ask question on whatever the document we have already trained, right, or stored. So while who will ask the question? The user will ask the question. So now this is the chatbot, for example, right? Now ask some question. The user will ask some question using this chatbot. Now what will happen? So now whenever this question will be will be asked, that question has to be embedded, right? First embed means because we have stored all those data in the database in an embedding way, right? So that has to be embed first, and then, so what it will do, now the query going into the LLM. Now the LLM will embed this particular user query, and it will convert it into some array of numerical values, right? So that's how it will be. Correct. So now what it will happen now, once the embed is available or converted to the question converted into embeddings, then we have to, that it will source that particular that particular embed, nearest neighbor embeds from the vector store, right? So you can say applying some uh, some what neural network algorithm, and source what are the neighborhoods, find the cluster, and where exactly what are the most appropriate answers for that particular question. That means what are the most appropriate, means what are the very neighborhood embeds available in the database. It will try to search those and try to convert into again the text, back to the text, a text, and then okay. So these are the user query, right? So once, if you see, once we have retrieved this data, what it will do, we got those data or encoded values, right? Encoded values, but not exactly the data, as I said, right? So now what we have to do, we have to re-rank it, re-rank it to the model and identify the score, what exactly that is. So after retrieval, the selected chunk, whatever the chunk we got selected from the database from the previous step, okay, might need further refinement. Yeah, we have to refine it, and ensure like those information what it got is more relevant, right? Remember, if you ask any question to Gemini AI or chatbot or something like that, sometime it will give you three different kind of answers, right? Because though it's try to identify very relevant answers, however, at the for the end user, which is more related information and a response, the user can choose that, right? So that way you can okay, regenerate means the LLM try to give you some alternate answers for that particular question, so that wherever you will be satisfied. So that way we are trying to, it has to be go through a re-rank process if required, right? Because there are a lot of information found from the LLM. Now it has to find out the which is more related answer or response, right? It will try to go through a cross encoder model, right? Which will try to validate. Ideally, it's a validator model, right? It will try to validate and then try to identify the highest score. Out of this is the query, chunk 1, chunk 2, chunk 3, and try to identify the scores. And out of scores, in this re-ranking step, the more sophisticated model, that's called often a cross encoder. Okay, so so that cross encoder, we'll talk about this cross encoder sometime later, but it evaluates the initial list of retrieved chunks alongside the alongside the query and assign a score to the every chunk, right? So now then it will identify which has the highest score, which chunk has the highest score, will be converted into as a final response or final answer, right? So that's how it goes through, right? So if you see the final response, this is the kind of final response you can see here. So now in this final, on the final response, what do you see? So this is the prompt template here. Whenever we build, our chatbot or our Gen AI application, right? The Copilot, there we have provided some context, how to answer the question to the user. So whenever the answer will be provided to the user, it will always comes with a template. So we are defining this particular template, or you can use any predefined templates as well. So that using that template, the LLM will create the response and stream to user, right? If you see when you are typing in the ChatGPT, so your answer is coming like typing, right? Your answer is coming with typing. That's called stream, right? It's stream. Or you can also configure as a one shot. Means first it will generate and give you the answer. So that way it will try to like it will show like typing. LLM is typing, kind of thing, right? Then it will give the answer in one shot. But if you go with the streaming way, then it will try to give you the response with word by word. So that just looks like it's the AI is writing the answer for you, right? So it's kind of that. So in this, once the most relevant songs are re-ranked, they are now fed into the LLM itself, right? So now this model combines this particular, if you see this particular LLM model, right? It combines the user's original query with the retrieved songs in our previous, on the previous step, right? The retrieved songs in a prompt template. The prompt template, we are trying to put it to generate a response which is very much synthesized and from the documents we have already provided previously, right? So that's how the whole uh, response getting generated from the provided document itself, right? So now we'll talk about a little bit RAG evolution. Okay, now we build the whole RAG application. Now, how can we evaluate like how good our chatbot is? How most related information we are able to get from the chatbot itself, right? So in that case, so let's, for example, we are asking for some question. We have given some financial data into the train it and store it into the vector database. So now we are asking, okay, what is the uh, revenue, total revenue for last quarter for company Apple. But if in the response, it's giving you instead of giving the revenue related answer, it's trying to give you the sales related answer. Then it's not related. Those are not related at all. Your question is not the answer is not fitting to the question, right? So you are looking for some different answer. So how you evaluate those kind of like how good your rack system is, right? So in this case, so typically when evaluating any rack system, we don't have access to human annotated data sets or references that answers, since the downstream application can be highly specific due to the capability of LLMs. Whenever we are training any input data, we are not annotating that, okay, this is revenue data, this is sales data, this all these things, right? Because while we are asking, it has to go through the whole process and identifying the right answer or response, right? Therefore, we prepare self-contained or reference-free matrix that capture the quality of the generated response. You can say the quality is Q, right? So in this case, we can say quality is Q of the generated response, which is precisely what matters in RAG application, right? So the quality is what we just need to understand, right? If the quality is good, then we'll go. So most of the cases, or if you are building a bigger RAG application, so most of the time we always prefer to get a reviewer into the system, in the sense like while you are creating any chat application, we always uh, we used to have a we should always have a space where we can able to get the feedback from the user, right? In the sense like if we get a feedback from the user can say, okay, this is good, this answer is good for my question. Now the RAG system will again learn accordingly. Okay, you can feed that feedback to the LLM system. Okay, last time you have given 3 answers, but out of 3 answers, this answer was very the this answer had the right quality, and it was very related to the question what user asked, and users mark as a thumbs up for this particular answer. Now next time when any user asks that kind of question, the LLM now understand, okay, I shouldn't provide the other two kind of response. Rather, the response it's given as a thumbs up, that kind of response it will try to give to the user. So there are a lot of things you can customize to build the whole thing, right? So that's how it talks. Thank you. Please subscribe and share and comment.